students, so have you ever observed the world around you and noticed that there are so many different things that exhibit unique properties? For instance, there are few things that can flow easily while the others cannot. Then there are few substances which can be given a new shape to, and they are compressible while the others retain their shape and are incompressible. So why does that happen? What makes these things different from each other? To answer these questions and to understand this fascinating world of physical properties, we study states of matter. In this exploration, we will delve into the distinctive characteristics of solids, liquids and gases, uncovering the underlying reasons of their varied properties and behaviors. So, before diving into this chapter, let's first understand that what all topics are we going to cover in the following video. So, we'll be talking about how solids, liquid and gases are different from each other in terms of their particle arrangement, the separation and the motion. Then we'll talk about how these states are interconverted into each other. We'll discuss some terms like melting, boiling, evaporation, freezing and condensation. Then we'll understand how the effect of temperature and pressure changes the volume of a gas. We'll also talk about kinetic particle theory, and at the end of this chapter we will understand what is diffusion and how the rate of diffusion depends on the molecular mass of a substance. First, define what is matter. Now, matter is anything around you that occupies space and has mass. Matter is made up of tiny particles which are atoms and molecules. There are three types of matter: solid, liquid and gas. Next, how are these three states of matter different from each other? On the basis of the particle separation, their arrangement and the motion. So now let's first discuss about solid. If you can see in this diagram, the particles present in solid are in an orderly form. Okay, they are in a regular arrangement, and because they are so tightly packed to each other, they are unable to move. They simply vibrate at their place. So they are packed closely together in a regular arrangement or lattice, and they are not able to move. They just vibrate at their fixed position. Okay, now what is lattice? Lattice is 3D representation of the arrangements of particle. Okay, it's the 3D representation of particles which are arranged. All right, next is your liquid. Now, did you see the diagram? The difference between first and second? The particles arranged in solid were so close to each other in a proper manner. But in case of liquid, the particles are less closely packed together, or I can say that there is intermolecular spaces present between the particles, and hence they can move around past each other. Okay, and they are arranged in a irregular arrangement. Okay, students, now your third state of matter is gases. If you can see in this diagram, the particles are far apart from each other and they can easily move. Why? Because the intermolecular spaces between them is large. Okay, and they are spread very far apart from each other. They are arranged in irregular form and they are easily movable. Okay, next, now let's try to understand few properties of solid, liquid and gases. So first property is volume. During the beginning of this chapter, I showed you a water bottle. Okay, and I told you that the volume of solid and liquid remains the same. So we already have answered this. Okay, but in case of gases, the volume cannot be fixed. Okay, it keeps on changing. Next is, let's first take compressibility. This also I have explained you in the beginning of this chapter. So I have a bottle. This is made up of solid. I try to compress it and I am unable to. Okay, so solids are incompressible. They cannot be compressed. But the liquid moving inside of it, the particle separation was lesser. Okay, therefore it is slightly compressible. Okay, But gases, the particles are far away from each other, the intermolecular distance is greater, therefore they can easily be compressed. You can think of a balloon while we are explaining the compressibility. Okay, so if you have a balloon, you try to compress it and then it gets burst out. Okay, so next is shape. The solid, which is this bottle, it retains its shape. I cannot change the shape. Why? Because it is not compressible, so it is fixed. In case of liquid and gases, because they have irregular manner of arrangement of particles, okay, there is intermolecular distance between of them and they can be compressible, therefore it takes the shape of the container they are kept in. The liquid inside of it has taken the shape of this bottle. If I put this liquid in some other vessel, it will take the shape of that vessel. Okay, students, therefore the shape of liquid and gases are not fixed. Okay, the fourth property is density. Now what is density? Now density is a way of expressing how much of matter is contained by specific volume. Okay, if you can see this diagram, this is solid, this is gas. How many particles can you see in this cube? The solid has more particles and the gas has less particles. Okay, so the density of solid will be high, that of liquid will be moderate, and for gases, because the number of particles is less in the same volume as that of solid and liquid, therefore the density is low. You should know, students, that density is nothing but mass over volume. I hope you understood this. You can pause this video here and you can write down these properties. All right, students, I hope you must have noted this. Now let's move on. So I have a question for you. Let's read. Mercury, oil, water vapor, common salt. At 20 degrees Celsius, which of the substance above, A part says, does not have a fixed shape, a volume, and can be compressed? So these three properties are shown by which state of matter? They are shown by gases. Right, students? We have already discussed the properties of three states of matter and these three properties are shown by gas. Now we have to check which amongst of these is a gas. So mercury oil is a liquid, water vapor is a gas, and common salt is solid. So my answer for A part will be gas, which is water vapor. Now B part. Now in B part they are asking contains the most orderly arrangement of particles. Most orderly arrangement of particles. We have seen the diagram and we know that the state of matter which shows the most orderly states of matter is, a most orderly arrangement of particles is solid. So in these options they have given, the solid is common salt. So the correct answer for B part will be common salt. If you wish to pause this video here and write down this question, you can do that. All right, students, you must have written down this question and solved the answer as well. Now, you must be wondering if we can change the state of matter. Yes, we can. You have an example. For example, you have an ice. That's a solid. If I want to convert this ice into water, what do? I change the temperature of it. Okay, I simply keep it out of the refrigerator. Okay, by doing that, I'm actually increasing the temperature of that solid. Okay, so when we increase the temperature of a solid, the bonds or the particles present in that solid gets separated out. Okay, and thereby they gets converted into liquid. And similarly, if I want that liquid water to get converted into gas or vapor, what do? I keep it outside. Okay, either in the sunlight or I increase the temperature and try to boil it so that that liquid gets converted into vapor. So now let's understand in depth that how do we convert these three states of matter into each other. Before understanding that, let's first talk about what is kinetic particle theory. So kinetic particle theory explains that each and every atom in a lattice is in constant motion, and what causes them to move? They have this energy called kinetic energy, which makes them able to move around. Okay, now let's read few points of kinetic particle theory. So a theory which accounts for the bulk properties of different states of matter in terms of the movement of particles that I've already explained. So when substances are heated, the particles absorb thermal energy, and this thermal energy gets converted into kinetic energy. Okay, and by this kinetic energy they can move freely, all right, which is converted into kinetic energy. This is the basis of your kinetic theory of matter. Next, heating a solid, which we have taken an example of a ice. So when I keep the ice out of the refrigerator, it is subjected to a higher temperature. Its particle, it causes the particle to vibrate more. Why? Because increasing the temperature means that the particles are absorbing this energy and converting this into kinetic energy, which is making them to move faster. Okay, as the temperature increases, the particle vibrates. It vibrates fast, so much that the solid expands until the structure breaks. Okay, and the structure breaks to form what? The structure of a liquid. Okay, this is when the solid melts into a liquid. Now next point is, heating a liquid causes the particle to move and move faster and spread out. Some particles at the surface gain sufficient energy to overcome these intermolecular forces. What were intermolecular forces? So suppose we have this solid and the particles inside of them. So they are placed so closely to each other. Why? Because of the forces which are present between of them. Okay, so we are talking about the forces which hold on to these particles together. Okay, this is when a liquid starts to evaporate. Now let's understand how these states of matter are converted. Okay, so if we wish to convert a solid into a liquid, the temperature is increased. Why? Because I need to break the bond between them so that these particles move apart from each other. And this conversion is known as, solid into liquid is known as what? Melting. Okay. Next is, when we have to convert liquid into gas, what do we do? When you have water and you want that water to convert into vapors, we boil it, okay, or we keep it outside in sunlight, right? What happens? We are increasing the temperature, and thereby the particles present in liquid are gaining the kinetic energy, they are absorbing the energy, and therefore they move far away from each other, okay, and hence we are getting the lattice that of gas. So this is called as vaporization, because liquid is converted into gas, or we can also call it what? Evaporation. Okay. Now the other way, if I have to convert gas into liquid, now what am I wanting? These particles to come close to each other. So I want these particles to form bond between of them. Okay, so I do not have to give energy, rather I have to put them in low temperature situation. Okay, I have to lower down the temperature, so these particles lose energy, they do not have much kinetic energy to move far away from each other, and they come closer and form bonds. Okay, so when gas is converted into liquid, that conversion is known as what? Condensation. Okay. Now our next conversion, when I have to convert liquid into solid, what do? You simply put that into your refrigerator, okay, or the freezer. Okay, while doing that, what are we doing? We are decreasing the temperature, and hence these particles come closer to each other, forming a lattice as that of solid, okay, wherein the particles are put in a orderly form. Okay, and therefore this is called as freezing. The conversion of liquid into solid is known as freezing. Okay, now you must be thinking that, ma'am, Can we skip the liquid state and we simply convert solid into gas or gas into solid? Yes, we can. There are few compounds, for example, iodine, camphor, naphthalene, or dry ice, which is also called as solid carbon dioxide. They show the property of sublimation. Now, what is sublimation? Sublimation is the process of conversion of solid into gas directly, skipping the liquid state of matter. We will understand sublimation in your further part of this chapter. So now students, you can write this thing down. I hope you have written this thing down and you have understood the basic knowledge behind how these states of matter are changed. Now let's see how the change of states take place in the terms of energy. Okay, so the solids, you know the diagram of solid exactly. Okay, it's something like that when the particles are close to each other. So what happens? These solids absorb energy, and what do they do with this energy? They break the bond which are present between of them, okay, and thereby increasing the intermolecular distance. Okay, that's how they gets converted into liquid. So solid absorbs energy, then they gets converted into liquid. Okay, then if we want this liquid to get converted into gas, simply we have to do the same thing. We will provide energy or increase the temperature. Increasing the temperature means we are providing energy, and that energy the particle of these lattice are absorbing. Okay, so the liquid absorb this energy and thereby, for example, this is liquid, thereby breaking the bond, and these particles move far away from each other. Okay, and therefore it gets converted into gas. Okay, now let's understand the other way around. So the gas is converted into liquid. How do we do it? Now we want the particles to come closer to each other. So what do? We do not give them energy. Rather, they release energy and they form bond between them. Okay, they form bond between them and they gets converted into liquid. Okay, they release energy when gas is converted into liquid. Why? Because the bonds are being formed between the particles. Then when liquid gets converted into solid, similar thing happens. Why? Because the particles want to come closer to each other. The solid, we know that the particles are arranged in an orderly fashion, right? So the bonds are formed, and therefore the energy is being released. Now a similar thing, when solid gets converted into gas, the particles have to break their bond, correct? And because of that, the energy is being absorbed. We have to increase the temperature and they absorb this energy so that the bonds are broken down and the particles move far away from each other. But when gases gets converted into solid, which is sublimation, yes, I know you know. So in this case, what happens? The bonds are being formed, okay? And we do not have to provide energy, rather they will release energy so that the bonds are being formed. Okay students, I hope it's clear. Now from this we can understand that there are two processes happening. Which one? Endothermic reaction or endothermic process and exothermic process. Now what is endothermic process? When the heat is given in, or when the energy is absorbed, that process is known as endothermic process. So for example, if I ask you that when solid gets converted into liquid, is it an endothermic process or an exo? You will answer me it's an endothermic process, ma'am. Why? Because the energy is being absorbed. That is why it is an endothermic reaction. Similarly, when liquid gets converted into gas, it is an endothermic reaction. Okay, but when energy is being released, when any particle, any substance releases energy during a process, that is known as exothermic process. You can remember it by this EX exothermic and EXIT, which is exit. So the energy is exiting from the particle. Okay, if you wish to write this thing down, you can pause this video here and you can note down this. Alright students, now let's understand few keywords or the conversion processes which we have already discussed. Now let's read. Okay, the definitions. Okay, the first one, which is evaporation. What was evaporation? When liquid gets converted into gas, that was evaporation. Okay, the process that turns a liquid into gas or vapor, that is known as evaporation. In that case, what is happening? We have to provide energy so that the bonds are broken down, and therefore it occurs when heat breaks the bond that holds the particle together. Okay, next one is melting. Now what is melting? When solid gets converted into liquid, or when you have an ice and you keep it outside, it gets converted into liquid. That process is known as melting. So the process of conversion of solid into liquid. It occurs when heat breaks the bond that hold the particle together. Okay, next one is condensation. What is condensation, students? So the reverse of evaporation. What was happening in evaporation? Liquid was converting into gas, but in condensation the gas or vapors get converted into liquid. Okay, it is the process of conversion of vapor or gas into liquid. During this, heat is given out. So what type of process is condensation? It is exothermic. Why? Because heat is given out, and the above two processes where they need heat or they absorb heat, these are endothermic. Okay. Now next is freezing. Freezing is a phase transition in which liquid gets converted into solid. When you put water into your refrigerator and it gets solidifies, or it gets converted into ice, that is termed as freezing. Okay, when its temperature is lowered below its freezing point. Next is sublimation, the process when the liquid state is skipped and the solid gets converted into gas directly, or the gas gets converted into solid directly, okay, without becoming a liquid first. That is sublimation. Now next is volatility. Now what is volatility? So there are few liquids which gets evaporated very easily, okay, or which has low boiling point. For example, ethanol or acetone. These are the liquids, if you keep it outside for like 5-6 minutes, it gets evaporated so quickly because they have low boiling point. Okay, so this type of liquid is known as volatile liquid, and the property of getting evaporated very quickly is known as volatility. Okay, the property of liquid to get evaporated easily and it has low boiling point is volatility. You can also mention few examples like ethanol and acetone. Acetone is also present in nail paint remover. Okay, so you can write this thing down, students. All right, students, now I hope you have better understanding of these definitions. Let's move on to the next slide. So I have few questions for you. If you wish to pause this video and try doing it yourself, you can pause this video. Okay, now, so the question says, in which changes do the particles move further apart from each other? So the particles are moving away from each other. So in case of solid to liquid, the particles break the bond between them and the intermolecular distance is like maximized. Okay, so my answer should have Z. And in case of liquid to gas also, the particles move away from each other. So the correct answer should be Z and Y, which is D. Okay, students, now the second question. Diagram X, Y and Z represent the three states of matter. This is the diagram. Which change occurs during boiling? Okay, so if you have studied the terms well, which we have discussed in the previous slides, you would answer this very quickly. So what happens in boiling? The liquid gets converted into vapors. Okay, so Y should get converts into Z. Okay, so my answer should be Y to Z, which is B. Okay, students, I hope you understood how we did these questions. Now let's move to the next part. Okay, now effect of impurities. Okay, now we know that water boils at what, 100 degrees Celsius. Okay, and it freezes at 0 degrees Celsius. But what if I add some impurity in this water? What if I add some salt to this water? What will happen? How will this data change? So I have a table for you here. Okay, these are melting point and boiling point of few pure substances given here. For water, if we are considering, the melting point is 0 and the boiling point is 100 degrees Celsius. Okay, if we add salt to it, or if we have a different sample, let's say sea water sample, then if we try to melt sea water, it will not melt at 0 degrees Celsius. It will rather take fewer more lower temperature, and it will melt at -2 degrees Celsius. And about the boiling point, it will not boil at 100 degrees Celsius. I'll explain why. It will boil at higher temperature, which is 102 degrees Celsius. Now, why this change in the datas? Because of the effect of impurities on the purity of water. So a pure substance melts or boils at definite temperature. Okay, the temperature is particular, or the temperature is fixed at which the pure substance melts or boils. Okay, the boiling point of pure substance helps us to test if my unknown sample has pure water or an impure water. All right, next is impurities often affect the values of melting point and boiling point of substance. Why? Because they change the values of boiling and melting temperature of a substance. Okay, students, you can write down this effect of impurities. All right, students, now let's try doing few questions on this topic. So the question says, why does seawater freezes at -1.8 degrees Celsius but pure water freezes at 0 degrees Celsius? As I told you in your earlier slide also, that for each pure substance they have a particular value of boiling and melting point. Okay, and when the impurities are added to it, the values changes. Okay, so, and the B part also, why does seawater boils at 102 degrees Celsius but pure water boils at 100 degrees Celsius? So what will be my answer? Because of the impurities added to the seawater becomes denser. Okay, the seawater is denser than pure water, as impurities are added to it. Okay, and therefore the mass of seawater increases but the volume remains same. Okay, thereby mass of seawater increases but volume remains same. So when the concentration of impurity is increased, the freezing point, I am writing FP. Okay, you can write freezing point. The freezing point is lowered than the normal freezing point, and the boiling point, okay, so I am writing BP, increases, okay, than the normal boiling point. Okay, so you can pause this video here and you can write down the answer, and let me know if you have any doubt on this topic. You can comment down below and I will definitely get back to you. Okay, students, I hope you have written this thing down. Now, next, other question. So, the question says, iodine is often seen as an example of a substance that changes directly from a solid to gas. However, data books that give the standard physical measurement for substances show values for the melting point 114 degrees Celsius and boiling point 184 degrees Celsius of iodine at atmospheric pressure. Explain why iodine seems to miss out the liquid stage if crystals are heated strongly in a boiling tube. So students, we have discussed in the definition part that what is sublimation. And I told you that there were few substances which show sublimation. One of them was iodine. So iodine is an example of a substance that shows sublimation. Sublimation means when the state changes from solid to gas directly, skipping the liquid state. So in the data booklet, it is giving that melting point of your solid iodine is 114 degrees Celsius and its boiling point is 184 degrees Celsius. So you can see that the difference between these two temperatures is very less, and therefore when we provide heat to solid iodine, it absorbs heat and then it quickly transforms into solid state to gaseous state, skipping the liquid state in between. So because our answer would be that because the difference in temperature, the difference in melting point and boiling point is less, therefore iodine skips the liquid state. And what if I want to see the liquid state of iodine? Then I have to use some other method. For example, I can use oil bath or I can use an electric heater and I can alter the temperature I am providing to this solid iodine so that I can observe my liquid iodine state as well. You can write down this answer as well now. Now, let's try another question. You can write down this question. If you wish to pause this video here and try doing it yourself, well and good, you can write. Okay, so let's discuss. So the first part of the question says, all the substances have negative values for their melting point. Which of them has the lowest melting point? So the data has been given to you for substances ethanol, then methane, and then mercury. Okay, the lowest melting point we have to check. For ethanol, the melting point is 117 degrees Celsius. For methane, it is minus 182 degrees Celsius. And for mercury, it is minus 30. So the lowest is minus 182 degrees Celsius, which corresponds to methane. Okay, so my answer for 1 is methane has the lowest melting point with minus 182 degrees Celsius. Okay. Now, the next part of this question. Which two substances are liquids at room temperature? Explain your answer. So, to check if any substance is liquid, we have to check two things. First, their melting point should be below room temperature. Room temperature is 25 degrees Celsius. Okay. And its boiling point should be above 25 degrees Celsius. Okay. So, let's check for ethanol first. The melting point for ethanol is less than 25 degrees Celsius. So yes, it satisfies one of the point. Next, the boiling point is greater than that of 25 degrees Celsius, correct? So one of my answer becomes ethanol. Okay. Next, let's check for ethane. Melting point less than 25 degrees Celsius, yes. But let's check for boiling point minus 164. Okay, it should be greater than 25, but it is less here. So this cannot be my answer. Therefore, methane cannot be liquid. Now, mercury. Let's check. Melting point is minus 30, which is less than 25 degrees Celsius, correct? Okay. Then, boiling point greater than 25 degrees Celsius, which is 357. Therefore, yes, it satisfies both the conditions. Hence, ethanol and mercury becomes my answer. Ethanol and mercury. And why? Because their melting points, I am writing MP over here, melting point, okay, their melting points are less than room temperature. Room temperature, we consider 25 degrees Celsius as room temperature, okay, and boiling point is greater than room temperature, okay, therefore these two are liquid. Now the last part of this question, third part, what effects does the presence of an impurity have on the freezing point of a liquid? So we have already discussed about the effect of impurities on substances. What happens when any impurity is added? The mass is greater and the volume remains the same, therefore more energy is required and the data is changed or altered, okay. Therefore what happens when impurity is added? The freezing point is lowered, okay, the freezing point is lowered when impurity is added. Okay, so if my question would have asked me what happens with the boiling point, then what would be my answer? That when impurities are added, the boiling point gets higher than the original boiling point. For example, if we take water, the melting point of water is 0 degrees Celsius, correct? Freezing point of water is 0 degrees Celsius. But if I take seawater, okay, seawater means water which have impurities such as salt, okay, then it will not freeze at 0 degrees Celsius, rather it will freeze at minus 1.8 to 2 degrees Celsius. Okay students, that is why when impurities are added, the freezing point also gets lowered. Now you can write down the correct answers. Okay students, so this is it for this class. In next class we will discuss about kinetic particle theory, then we'll talk about the heating curve and cooling curve, and at the end of this chapter, states of matter, we will discuss what is diffusion and how does it change according to the molecular mass of any substances, and with few more questions. Till then, keep learning and enjoy. Thanks for watching and I'll see you in the next video. Till then, don't forget to like, share and subscribe to our channel.